Imagine yourself drifting into a calm and distant century where the night sky carries a soft and familiar glow, yet holds dreams that humanity has only recently begun to understand. In this peaceful vision of the future, space mining is not a dramatic conquest, nor a noisy rush for treasure. It is something far quieter, born from decades of patient curiosity, gentle experimentation, and a slow realization that the solar system might hold resources that could support life and industry in careful, sustainable ways. Our story begins in the early 21st century, long before any large-scale mining happens. At this stage, the idea exists mostly in scientific papers, conference halls, and quiet laboratories. Researchers observe the composition of asteroids through telescopes, analyzing faint reflections of sunlight to guess what lies inside these drifting ancient stones. Many asteroids contain metals like nickel and iron, and some contain platinum group elements formed in the violent heart of long-dead stars. Others hold water ice mixed with carbon-rich material, leftovers from the early days of the solar system. None of this feels urgent. The world continues with its own rhythms, cities glowing softly at night, oceans rolling in endless patterns, and people living out their routines without ever feeling the need to look beyond the sky. Space mining remains a distant possibility, yet the seeds are quietly planted as scientists send the first small probes to visit asteroids up close. Each mission returns delicate fragments of insight, a handful of dust grains, a clue about rock structure, a whisper of information about how fragile or sturdy these bodies truly are. These early missions, like Japan's Hayabusa, NASA's OSIRIS-REx, and other future explorers, form a foundation for understanding. In laboratories on Earth, researchers examine tiny samples under microscopes, marveling at material untouched for billions of years. Every grain carries a story from an age when planets were still forming. This quiet knowledge begins to shape the imagination of engineers and economists who wonder what might be possible one day, perhaps not soon, but eventually. In this imagined timeline, robotics and artificial intelligence continue to grow in gentle steps. Machines become more precise, more autonomous, more capable of operating far from Earth with minimal intervention. Spacecraft design improves slowly as engineers learn to use lighter materials and more efficient propulsion. Ion engines, powered by tiny streams of charged particles, glow softly as they guide probes on long journeys that last not months, but years. Gradually, humanity starts to imagine that retrieving resources from space might not be impossible. It might simply require patience, careful study, and collaboration across nations. In this calm future, there is no rush. The idea is not to strip the solar system or overwhelm Earth with new materials. Instead, the goal is to understand how space resources could support space exploration itself. reducing the need to launch everything from Earth's deep gravity well. Water becomes the first resource that captures the world's attention. Not because it is rare in the universe, but because water in space could become fuel, oxygen, and life support. If future missions could extract water from asteroids or from shadowed regions of the moon, it could make distant exploration far easier. This possibility becomes a gentle turning point. Engineers begin sketching designs for robotic miners that could heat asteroid material, releasing vapor to be collected and stored. Still, nothing happens quickly. Even by the 2050 seconds, in this possible timeline, space mining remains a series of experiments, small probes landing softly on selected asteroids, testing drills, scoops, and anchors. Each landing teaches humanity how surfaces behave in tiny gravity fields. Dust floats rather than falls. Rocks break differently. Tools must adapt. People on Earth hardly notice these changes. Life continues calmly with the same joys, challenges, and everyday routines. But quietly, almost like a whisper carried by the wind, the idea grows. Economic researchers begin to discuss how additional off-Earth resources might stabilize supply chains decades later. Environmental scientists consider how space-derived material could reduce pressure on terrestrial ecosystems if used wisely. Space agencies refine long-term plans, imagining missions that depend not solely on Earth, but on shared infrastructure between worlds. And so, Part 1 ends not with an achievement, but with a mood, a calm recognition that humanity has taken its first small steps toward a potential future. Space mining is still only a seed, but seeds, when given time, light, and patience, can quietly grow into something that reshapes entire landscapes. As the years drift softly toward the middle of the century, the idea of gathering resources from space continues to unfold in slow, deliberate movements. Nothing happens with the speed of science fiction. Instead, progress feels like a series of calm breaths, small achievements that build on one another, shaping a quiet foundation for what space mining might become by 2100. In this imagined future, the first true milestones come from robotic explorers. These spacecraft, shaped by decades of engineering improvements, glide through space with the silent confidence of machines built for patience. They rely on gentle propulsion ion engines that glow faintly like blue embers, and autonomous navigation systems that allow them to make tiny decisions on their own. Each action is careful, methodical, and designed for long, slow journeys. The early missions do not attempt to bring large amounts of material home. Instead, they focus on understanding. A probe might land on a small asteroid, anchor itself with soft mechanical legs, and extend a tiny robotic arm. The scoop it carries might only collect a few grams of dust. But those grams reveal patterns, the delicate mixture of minerals, the strength of rock in microgravity, the behavior of loose particles in near-weightless conditions. Engineers on Earth watch these missions with quiet fascination. They see how drills perform, how tools respond to unexpected dust plumes, how sunlight affects temperature-sensitive equipment. Each result gently corrects the design of the next generation of machines. By the 2050 seconds or 2060 seconds, if technological growth continues, it becomes possible to imagine robots that can gather slightly more material from a target asteroid. Not tons, not enough to shift any global economy, but just enough to test small-scale processing systems. Some missions might vaporize rock to extract water. Others might use low-temperature techniques to separate metals from surrounding material. These early experiments feel almost like delicate art projects, crafted with care and curiosity. The first small processing units could float in orbit around Earth or the Moon, acting as tiny refineries. Their internal chambers may be no larger than a household appliance, but they demonstrate something profound: the ability to transform raw asteroid material into usable substances without needing Earth's heavy machinery. This quiet achievement becomes one of the most important steps in the story, even if few people outside the scientific community notice it. Meanwhile, Earth continues its own path. Cities gradually adopt cleaner energy systems. Transportation evolves in subtle ways. Recycling grows more effective, allowing valuable materials to be reused instead of discarded. Economists observe that the demand for certain metals, those used in batteries, electronics, and advanced manufacturing, continues to rise, but they also see that sustainability practices are slowly improving. Against this backdrop of gentle change, space agencies begin proposing missions that rely on off-Earth resources. A spacecraft designed for deep space might carry less fuel at launch, depending instead on resupply from a small depot that could one day be filled using asteroid-derived water. Lunar habitats might use a mixture of local and imported materials. These ideas are still possibilities, not realities. But each possibility makes the next one feel a little more reachable. One of the most calming aspects of this future is that space mining does not emerge from competition or urgency. It grows from collaboration, curiosity, and the shared desire to explore responsibly. Nations coordinate their asteroid observations through international groups. Universities share data. Private companies combine resources to reduce risk. This cooperative pattern acts like a gentle current, guiding humanity forward. Back in space, the robotic miners continue their work. Some missions fail in quiet, harmless ways. Lost signals, frozen instruments, unexpected surface conditions. Others succeed beyond expectation. Each mission, successful or not, becomes part of a slow learning process that stretches over decades. By the late 2060 seconds, the world begins to sense that something subtle is shifting. What once seemed like distant dreams now feels like the early steps of a new kind of industry. Not a loud or overwhelming one, but an industry that could grow organically, shaped by need, science, and careful planning. space mining remains small, experimental, and fragile. But it is also undeniably real. And as robotic explorers continue traveling through the serene darkness of space, humanity starts to imagine how these gentle steps could eventually create pathways for larger transformations that might, quietly and gradually, influence the global economy by the year 2100. As the timeline drifts into the later decades of the 21st century, the early experiments in space resource extraction begin to settle into a gentle rhythm. The work is still small, still careful, still far from being a full industry. Yet something subtle is changing. The scattered pieces of technology and knowledge, robotic miners, tiny refineries, navigation systems, asteroid catalogs are beginning to connect in ways that hint at a quiet emerging network. Imagine a scene in this peaceful future. Orbiting above Earth, a small processing platform glimmers in the sunlight. It is not large or imposing, but delicate, almost elegant in its simplicity. It turns slowly, gathering warmth on its solar panels as robotic modules move gently along its frame. Inside, systems built from decades of research test how to store water extracted from asteroid samples. A fraction becomes liquid, a fraction becomes ice, and a fraction becomes vapor, each phase studied with patience. This platform is one of the first supply nodes in a possible space-based resource chain. It does not produce much, but what it produces is meaningful. It shows that off-Earth materials can be harvested, stored, and transported in small amounts without relying entirely on supplies launched from Earth. A few 100,000 kilometers away, in the calm environment of cislunar space, another platform orbits near the Moon. This one focuses on different tasks, perhaps the gentle heating of lunar regolith to extract oxygen, or the testing of lightweight alloys produced from samples brought from a nearby asteroid. Again, the quantities are tiny, but the knowledge gained is immense. Engineers learn how to operate machinery in harsh vacuum, extreme temperatures, and microgravity without constant human intervention. In this imagined future, spacecraft travel between these nodes with slow grace. They are not rushing, they are drifting along predictable, fuel-efficient trajectories known as low-energy transfer routes. These routes take advantage of natural gravitational balances, allowing vessels to move between worlds using less propellant. This gentle dance around Earth and the Moon becomes a key part of the early space supply network. Meanwhile, robotic miners continue to visit selected asteroids. Some asteroids are metallic, dense with iron and nickel. Others are carbon-rich, containing water-bearing minerals. Each type offers a different lesson. Robots practice anchoring techniques, drilling patterns, and sample return processes. Gradually, they gather enough information for planners to categorize asteroids based on accessibility and resource potential, not as guarantees, but as possibilities for future missions. As this quiet network grows, the world on Earth begins to feel small ripples of change. Space agencies cooperate more closely, sharing their data to reduce the cost of exploration. Universities teach new courses on asteroid engineering and resource systems. Industries that once seemed unrelated, such as robotics, materials science, and renewable energy, find themselves connected through shared research challenges. And yet, despite these developments, life on Earth remains peaceful and familiar. People do not wake each morning thinking about asteroids or orbital depots. Instead, the changes blend softly into the background, like distant stars that grow brighter only when one chooses to look carefully. By the 2070 seconds, or 2080 seconds in this imagined future, the supply network becomes a little more reliable. Not large, not fast, but steady. A small amount of asteroid-derived water might be delivered to an orbital station every few years. A lightweight structure made from space-processed metal might be used to support a scientific telescope. Spacecraft designed for deep space missions might refuel in orbit instead of carrying all their propellant from Earth. These shifts reduce some of the financial strain that once held back exploration. Launching heavy materials becomes less necessary. Missions become more ambitious, not because of sudden breakthroughs, but because the slow, patient construction of infrastructure allows them to be. On the Moon, small facilities might begin producing simple materials for local use. They could test building blocks made from lunar dust or create insulation layers for habitats. None of this is dramatic, but each quiet success brings humanity one gentle step closer to long-term presence beyond Earth. The supply network also offers new forms of economic potential. Companies and governments that invest early might find themselves supporting technologies that later become essential, like autonomous mining systems, fuel storage techniques, and modular space construction. The global economy begins to adjust in tiny increments as new opportunities appear. Yet nothing overwhelms the world. The transformation is slow, almost dreamlike. It spreads gradually, like light from a rising sun touching different parts of the landscape, one by one. Space mining is still not an industry in the way Earth understands industries. It is more like the scaffolding of a future industry, thin, delicate, but growing stronger with time. And as the 21st century continues unfolding, this quiet network may become the foundation upon which deeper changes rest. Changes that could shape the economic rhythms of the year 2100 and beyond. Not through sudden shock, but through long, gentle evolution. As the imagined future drifts further toward the late 21st century, the soft beginnings of a space-based supply network start to mature. The transformation is still calm, still subtle, and still unfolding with the patience of a slow sunrise. But something important is taking shape. The gentle expansion of an off-world industry, built on lessons learned over decades of robotic exploration and careful resource handling. By this time, robotic miners have become more refined. They are not faster or louder, but more graceful, more reliable, and more independent. Their movements show a confidence earned through countless test missions. Some operate near Earth, visiting small asteroids that pass close to our planet. Others travel farther, heading toward targets selected for their accessible orbits and gentle rotation patterns. These missions do not seek vast quantities of material. They focus on consistent, predictable extraction in small amounts. The materials they collect: water ice, metal-rich grains, carbonaceous fragments are delivered to processing stations that float quietly in cislunar space. Inside these stations, automated systems warm, separate, melt, and refine the material with a delicate precision. The output is modest: small tanks of water, containers of simple metals, and tiny reserves of oxygen. Yet each product has value in the growing orbital economy. Water becomes one of the most useful substances of all. With slow and steady extraction, it can be split into hydrogen and oxygen to create fuel. This fuel supports spacecraft operations farther from Earth. It allows satellites to adjust their orbits more often. It enables scientific missions to venture deeper into the solar system with fewer constraints. The presence of off-Earth fuel gently reshapes long-term mission planning, making exploration less dependent on expensive Earth launches. Metals extracted in space also start to play a role. Though production levels remain small, they offer an important test of manufacturing techniques that work in low gravity. Factories in orbit, no larger than shipping containers, begin forming thin beams, plates, and simple components from asteroid-derived metal. These early pieces might support the assembly of telescopes, communication arrays, or orbital habitats, instead of launching every part from Earth. Some structures now quietly grow in space, piece by delicate piece. This shift brings a new sense of possibility. The idea of building large scientific instruments, massive telescopes with mirrors assembled from space-sourced components, or observatories positioned far from Earth's interference, feels closer than ever. Engineers imagine solar power stations constructed in orbit, their wide panels created without the need for heavy launches. These ideas remain in the realm of potential, not certainty. But the groundwork is being laid with each passing year. On the Moon, small industrial facilities begin to support local infrastructure. They might produce radiation shielding from lunar soil, or create simple bricks using regolith as raw material. These structures could help future habitats stay safer and more self-sufficient. Lunar operations may not rely entirely on asteroid resources, but they benefit from the growing network of tools, technologies, and autonomous systems developed for space mining. The global economy on Earth begins to feel these changes in quiet ways. The demand for advanced robotics rises as companies adapt their manufacturing to support space operations. New careers emerge in mission planning, orbital construction, and off-world materials research. Universities create programs focused on extraterrestrial geology, in-space production, and long-duration autonomous systems. International agencies cooperate to standardize safety protocols and resource sharing agreements. Economists notice that markets for certain materials become more stable. Rare metals used in electronics may not be replaced by asteroid sources, but the potential for future supplementation helps moderate long-term price fluctuations. Meanwhile, the ability to access fuel in space gradually lowers the cost of scientific missions, which benefits the entire global research community. Yet throughout all of this, life on Earth remains calm and familiar. People still work, travel, cook, laugh, dream, and rest under the same stars humanity has always known. The changes happening above them are gentle, unfolding at a scale and pace that feels almost meditative. Most individuals might never think about asteroid mining directly, but they benefit indirectly from improved communication systems, advanced materials, or new scientific discoveries made possible by space-based infrastructure. By the late 2090 seconds in this imagined timeline, off-world industry has become a quiet partner to Earth's economy. Small streams of resources flow between robotic miners, processing stations, manufacturing modules, and lunar outposts. These streams are not large enough to overwhelm markets or redefine civilization overnight. Instead, they serve as a supplementary ecosystem, a network that helps humanity explore more sustainably, build more efficiently, and plan with greater confidence. The soft expansion continues without rush or noise, like gentle waves gradually shaping a shoreline. And as the century nears its end, these early structures and supply chains could form the framework for the deeper transformations yet to come. Transformations that may influence how nations cooperate, how economies grow, and how humanity gently steps into the wider solar system. This is one possible future scenario, a quiet imagining of what the year 2100 might look like if technology continues to grow gently and steadily, and if humanity learns to use space resources wisely. Nothing here is promised, only a calm exploration of what could unfold. As the decades drift onward, the early sparks of space mining might begin to form something larger, something deeper than anyone first expected. By the late 2080 seconds, and moving toward 2100, the solar system could start to feel connected. Not in a loud or busy way, but in a quiet, measured rhythm, like a network of distant towns slowly building roads to one another across a wide countryside. It might begin with simple trade, small cargoes drifting from automated mining stations to orbital depots. But as reliability improves, and as the economics potentially strengthen, the routes could grow into regular pathways. A ship might glide from a lunar foundry carrying tanks of refined helium-3, while another moves on a long arc from a near-Earth asteroid with carbon, metals, and water ice. The sky could become a slow, graceful ballet of purposeful movement. Nothing rushed, nothing chaotic. simply a gentle flow of materials following predictable patterns. Economists of that era might speak about a cosmic supply chain, though it would still be humble compared to Earth's vast networks. The value, however, could be enormous, not because of speed, but because of location. A kilogram of water delivered to an orbital station could save a tremendous amount of energy by avoiding launch from Earth's deep gravity well. A batch of nickel-iron alloy shaped in low gravity might have a purity difficult to produce on Earth. These small advantages might create new industries, each built on subtle efficiencies. And somewhere in this unfolding web, energy might quietly become the star of the story. Helium-3 from the lunar regolith, if fusion research continues to evolve, could become a prized resource, not guaranteed, but potentially transformative. Even tiny amounts might hold significant worth if fusion reactors advance enough to use it effectively. The moon could shift, slowly and calmly, from a distant desert to a gentle supplier of fuel for the clean reactors illuminating cities across Earth. Meanwhile, asteroids rich in platinum group elements could supply high-tech manufacturing without disturbing Earth's landscapes. Again, nothing certain, but possible. Factories might float in orbit, taking advantage of microgravity to create delicate materials, or assembling long structures too fragile to support their own weight under terrestrial gravity. This could lead to habitats, telescopes, or solar arrays stretching gracefully across black space, glimmering silently like slow-moving lanterns. With each success, a new economic model might emerge, one that blends terrestrial needs with off-world opportunities. Earth would still be the heart of human life, but space could become the lungs and bloodstream, carrying resources where they're needed, relieving pressure on the planet below. The goal would not be conquest, but balance, a gentle sharing of burdens. Labor itself might shift. Miners would not swing pickaxes on asteroids. Instead, technicians, programmers, and robotics specialists on Earth might oversee fleets of autonomous machines operating millions of kilometers away. Work might become calmer and safer, less about physical danger and more about careful guidance. Some people might even find comfort in the steady hum of remote operations, knowing their efforts contribute to something larger, something expanding quietly beyond Earth. Nations could join consortia, pooling resources to avoid conflict. Space mining might become a cooperative possibility, with shared rules about safety, debris management, and environmental responsibility both in space and on Earth. If diplomacy continues peacefully, the solar system could become a stage for collaboration rather than competition. And throughout all of this, the presence of space in everyday life might become so ordinary that children born in 2100 could look up at the night sky and see not just stars, but tiny glints of distant structures. To them, it might feel normal, the way airplanes once became normal to earlier generations. They might grow up learning that some of the energy powering their homes arrived from fusion plants fueled by lunar materials, or that some of their electronics were built using metals gently harvested from drifting asteroids. It would still be a quiet world, a peaceful world, where most people lived their lives on Earth, surrounded by familiar landscapes. But space, instead of feeling unreachable, could feel like a calm extension of humanity's backyard. A place where resources flow like a steady tide, carried by delicate pathways linking worlds together. And as this trade web strengthens, the global economy might experience a new kind of breathing. Slow, stable, and spacious. Earth could have more room to heal. Industries might have more room to grow sustainably. And humanity might feel the first hints of what it means to be not just a planetary species, but a gently expanding one. This is still one possible future, a quiet imagining shaped by potential technology, uncertain progress, and humanity's hope for harmony. Nothing here is promised. Everything remains an unfolding possibility, drifting gently across the canvas of time. By the late 2090 seconds, the effects of space mining might begin to ripple through Earth in soft, gradual ways. Not sudden, not dramatic, more like the slow brightening of dawn after a long night. The world could feel a little less pressured, a little less strained, as industries adapt to new sources of materials arriving from beyond the sky. On Earth, the environment might breathe easier if mining operations shift away from sensitive landscapes. Forests, rivers, and mountains could see fewer disturbances. Cities might grow more slowly and more thoughtfully, no longer driven by frantic demand for rare metals or heavy minerals. Instead, Earth might focus on recycling, conservation, and gentle stewardship, while space-based resources supplement what the planet no longer wishes to give. This does not mean Earth becomes untouched or perfect. People will still need materials, energy, and technology, but the balance could gently tilt towards sustainability. Countries might set aside more land for restoration, turning former industrial regions into parks or renewable energy sites. Oceans might see fewer deep-sea mining plans, as the harsh need for certain minerals becomes less urgent. It's all only possible, but it paints a peaceful picture. Economists of this era might describe a shift in global value. Instead of racing to extract resources from the ground, nations might place increasing worth on knowledge, creativity, and the maintenance of Earth's ecosystems. What grows in importance is human well-being, clean air, clean water, stable climates, and healthy communities. The economy could gradually reflect the idea that Earth is a home to be cared for, not a vault to be emptied. The availability of off-world resources could also reshape geopolitics. Countries with access to space technology or partnerships with those who have it might find new opportunities. Instead of competing fiercely over rare metals or fuels, they might collaborate on shared space facilities, orbital factories, and lunar stations. agreements might form, aiming to prevent conflict and ensure that the benefits of space resources are distributed peacefully. This cooperation would not be perfect. Humanity rarely moves in a straight line. There could be debates, tensions, and difficult choices. Yet if leaders choose patience and wisdom, the solar economy might develop into something stable, predictable, and fair. A slow, calm expansion rather than a scramble for power. The idea of space for all might grow from a hopeful slogan into a lived reality. On the ground, daily life could also change in small, comforting ways. Electricity might become cheaper and cleaner if fusion technology matures and if lunar helium-3 becomes a feasible fuel. Some regions might rely heavily on solar energy collected by large orbital panels, which beam power down safely through microwave or laser systems designed carefully to avoid harm. These possibilities might ease the strain on Earth's grids, making energy shortages less common. Communities could warm themselves in winter, cool themselves in summer, and cook their meals with energy that drifted silently from the moon or from sunlight gathered far above the clouds. And as energy grows cleaner, air quality improves, allowing cities to breathe easier. Children might play under clearer skies, seeing stars their grandparents lost to light pollution. Education could shift too. Schools might teach not only mathematics and history, but also orbital stewardship, space engineering, and the ethics of using resources from beyond Earth. Young minds might grow up curious about the moon, asteroids, and the quiet machinery working among the stars. Some might dream of careers involving remote robotics, space agriculture, or planetary protection jobs that barely existed a century earlier. For older generations, this time could feel both strange and hopeful. They would remember a world where space was something distant, a place reachable only by a handful of astronauts. Now, they might watch ships rise on reusable launch vehicles almost as calmly as people today watch cargo planes take flight. They might see small dots moving across the night sky, knowing those dots are carrying water, metal, or data along predictable cosmic routes. Through all of this, Earth remains the heart. Space may become a source of support, but the planet below its oceans, forests, mountains, and cities remains the center of human life. The expanding economy does not pull humanity away from its home. Instead, it could give Earth the chance to rest, to heal, and to thrive under gentler conditions. As 2100 approaches, the world might feel a little more balanced, a little more spacious, and a little more hopeful. The quiet partnership between Earth and space could be just beginning, weaving together an economy shaped not by urgency, but by thoughtful possibility. This continues to be only one possible future, a calm imagining of what might unfold if technology progresses steadily and humanity chooses peaceful paths. Nothing is guaranteed. These ideas simply float gently across the imagination, inviting rest rather than certainty. As the century nears its final decade, everyday life on Earth could begin to feel subtly shaped by the presence of space resources. Even for people who never look up at the night sky, the changes would not be loud or overwhelming. Instead, they might arrive like a soft tide, small improvements here and there, each adding comfort to human life in quiet ways. Some of the shifts could be seen in medicine. If space-based manufacturing matures, microgravity environments might allow the creation of delicate biological materials like protein crystals or specialized tissues that are difficult to form on Earth. These could help researchers design better treatments, gentler therapies, and more precise diagnostic tools. Patients might never realize that something helping them heal was shaped far above the atmosphere, drifting serenely in an orbital lab. Construction on Earth might evolve as well. If lightweight, ultra-pure alloys created in microgravity become common, architects could design buildings that are strong yet graceful, using materials that were once too rare or expensive. Bridges could stretch farther, towers could rise taller, and homes could become more energy efficient. Cities might develop a softer, more open character, no longer confined by the limits of older materials. Transportation, too, might feel the influence. Shuttles and spacecraft designed for orbital travel could use fuels or components refined off-world. While most people would still travel only on Earth, the existence of a thriving space infrastructure might make global logistics smoother. Faster cargo routes, cleaner fuels, and more reliable supply chains could make everyday items more accessible. And somewhere within this quiet transformation, a new generation might begin to dream differently. Children growing up around 2100 could take field trips to local space learning centers, where holographic models show asteroids, mining stations, and orbital greenhouses. They might watch live feeds from robots exploring small bodies millions of kilometers away, seeing them carve paths through ancient rock or extract ice from shaded craters. Some students could grow fascinated with the moon, imagining what it feels like to walk slowly across its silent plains, where the sun rises and sets with almost dreamlike stillness. Others might be drawn to the engineering side, curious about how robots communicate across such vast distances, or how materials behave in the strange stillness of microgravity. The idea of working in space might feel less like fantasy and more like a calm, steady profession, safe, remote, and operated mostly from Earth. Societies might slowly change their outlook too. The awareness that resources can come from beyond Earth could inspire a global shift in perspective. People might begin to see the planet not as a closed container of limited wealth, but as part of a wider system filled with potential. Economic growth could become less about using more and more from Earth, and more about using things wisely, balancing what our home provides with what the solar system offers. Culturally, this era might inspire new forms of art. Musicians might create gentle symphonies influenced by the rhythm of distant orbits. Filmmakers could craft stories blending human warmth with cosmic scale. Writers might imagine peaceful futures where humanity isn't rushing to conquer new worlds, but instead learning to coexist gracefully with them. Painters might capture the soft glow of asteroid refineries or the serene silhouettes of orbital habitats drifting like lanterns in the dark. Even spirituality could shift subtly. Some people might find comfort in the idea that humanity's reach has extended into the quiet spaces of the cosmos, like roots stretching into fertile soil. Others might see deeper meaning in the cooperation required to maintain a peaceful off-world economy. The universe itself, the vast, silent backdrop of existence, could feel less distant, less separate, more like a companion. And in the midst of all this gentle transformation, humanity might become more aware of its fragility. The more we reach outward, the more we might appreciate the delicate beauty of Earth, the only place known to cradle life. Space mining, instead of pulling humanity away from its origins, could bring a deeper appreciation for our home. People might slow down, reflect more, and understand that even with all the possibilities among the stars, Earth remains a rare and precious sanctuary. By the time the century closes, the economic landscape might feel broader, less compressed within the boundaries of one planet. The strains that once seemed impossible to overcome could be softened. New careers might blossom, new innovations might bloom, and new dreams might be born, all carried gently by the quiet expansion of human capability. And yet, through all of this, life might remain simple for most people. They might wake, work, rest, and spend time with those they love, just as humans always have. But now, woven into the background of daily life, there might be a soft awareness that humanity is no longer alone within its own cradle. There is movement above, silent and steady, a gentle hand helping to support the world. As the year 2100 settles over the world, humankind could find itself standing at a gentle threshold, not a dramatic turning point, not a moment of loud celebration, but a calm, steady arrival into a wider existence. Space mining, once a distant dream, might now form a quiet thread woven through the global economy, supporting Earth in a way that feels natural, balanced, and almost serene. The solar system, once an unreachable backdrop, could feel like an extended neighborhood. Automated mining stations might drift like slow-moving outposts. Orbital foundries could glow softly as they refine metals in microgravity. Lunar facilities might gather helium, 3 grains from ancient dust, contributing to clean energy systems far below. And asteroid harvesters, operating with patient precision, might send steady shipments of water, carbon, and metals to Earth's orbit. But none of these structures would dominate the sky. They would exist quietly, in the background, like distant lights across a calm ocean at night. For most people, this cosmic infrastructure would simply fade into the rhythm of daily life, offering benefits without demanding attention. Earth might feel different in this new century. Its forests could be thicker, its rivers clearer, its skies calmer. With fewer pressures on terrestrial resources, landscapes once threatened by overuse might begin to heal. Old mining towns could transform into cultural centers or nature reserves. Former industrial zones might turn into parks, gardens, or laboratories dedicated to sustainable research. Earth would remain busy and lively, but touched by a quieter harmony. Global economics might also feel gentler. Instead of an urgent scramble for materials, nations could enjoy a sense of spaciousness, knowing that some supplies come from the vastness beyond. This doesn't guarantee perfect peace. No human era ever achieves that fully, but the tension around resource scarcity might soften. Instead of rivalry, more countries might choose collaboration, sharing, or jointly managing off-world facilities. The world's energy systems might glow with newfound stability. If fusion energy matures, powered in part by lunar materials, cities could enjoy clean, steady electricity. Lights would shine without strain, heat would flow without smoke, and industry could operate with an ease that generations before only hoped for. Even if fusion remains challenging, the increased use of space-based solar arrays might still offer abundant energy, gently transmitted to Earth. Families living in 2100 might notice the change most clearly in their sense of possibility. Children growing up in this time could see humanity not as confined to one world, but as a species with roots on Earth and branches reaching outward. School lessons might show live views of orbital habitats, where plants grow in cylindrical greenhouses, rotating slowly to create simulated gravity. Students might practice coding simple robotic systems designed to assist with remote mining operations. Even travel might evolve in subtle ways. Space tourism might remain rare, but orbital flights could become more accessible for researchers, engineers, or workers maintaining essential systems. These trips would be calm and well-planned, nothing like the adventures described in old science fiction, more like gentle ferries than daring voyages. Culture would continue to bloom under the influence of this wider perspective. Artists might paint moonscapes glowing under the long shadows of mining structures. Musicians might compose slow, drifting melodies inspired by the rhythm of orbital mechanics. Writers might craft stories about love, discovery, and home, set among the quiet stars. And through all this progress, there might be a shared understanding that Earth is still the center of everything meaningful. Even with access to materials from asteroids, fuels from the moon, and manufacturing in orbit, humanity's heart would remain here, in the forests, the oceans, the streets, the small moments of life that make us human. Space would help support life, but Earth would continue to define it. As 2100 unfolds, humanity might take a quiet breath and realize it has entered a new chapter, not through force, but through patience. A chapter where the global economy is supported by both Earth and the sky, where industry is cleaner, resources more abundant, and cooperation more natural. A chapter shaped by the gentle partnership between one small planet and the vastness surrounding it. And if this future arrives slowly, softly, peacefully, people might look up at the night sky, not with fear or ambition, but with calm gratitude. They might feel comfort knowing that far above, silent machines glide along ancient orbits, helping maintain the balance of life below. The story of space mining would not be the story of conquering the heavens. It would be the story of humanity learning to grow thoughtfully, extending its hands outward while keeping its feet firmly planted on the world it calls home. And so, the vision ends as quietly as it began, draped in possibility, gentle as starlight, and drifting calmly into the dreams of those who listen.